Hi, I'm John Tilka, a NASA co-op, and I'm here with Steve Bowen, a retired Navy captain and now a NASA astronaut.
Thank you. Hi.
I wanted to ask you about your experience in the Navy and how you guys use non-destructive evaluation when you're undersea.
Oh, well, non-destructive evaluation, you actually use it all the time. And obviously there's some highly controlled non-destructive evaluation that you get to use, radiography in the shipyard in particular. It's not something you can take underway with you, not something you can take to space with you. Ultrasound for pipe wall thickness, we'd use that. Vibration monitoring, even sonar itself, we use that on submarines to analyze ourselves and assess ourselves. In space, it's similar. It can be very similar at times. Obviously, we do a lot of non-destructive evaluation on the ground for systems before we launch them. I think the space shuttle external tank was a really good example of where they developed a very specific ultrasonic testing system before they shipped the tank. It was pretty neat to go and see. So non-destructive evaluation, it's been in sort of everything I've done since I graduated from college has had some little part of it, ensuring that the vehicles I've been living on have been safe to operate. And it covers such a broad range of things. I mentioned some of the more specific NDE techniques, but we even went to the point of, you're tapping on a pipe and you're listening and feeling for the response as you go along. And in space, a lot of what you're doing is similar. You're listening to the vehicle itself. You're listening for changes. You're listening for things that are not quite right. As you move around, if things move a little bit differently, and I know when we go out and do spacewalks, the teams on the ground look at the video to see how our movements affect the vibration of the space station to do some load testing. So it's sort of an everything sort of question, I guess, when you ask it like that.
Awesome. So how long does it take for you to live in this kind of vehicle to get a feel for the health? And
that's actually an interesting question because, we tend to fall back a lot on automated systems, and not always are they capable of picking up the subtleties and the trends and the programming of the human mind. So I always thought an intelligent operator was key to ensuring that we were getting the most out of this testing. Obviously, you can go back and you take data from a vibration monitoring system, and you can do a pretty high-level assessment of what bearing's going to fail, where the problems are. But somebody standing next to the pump doing that first cut often was able to pick up a lot of that stuff before we could even get it analyzed. Similarly, on either vehicle, as I said, if you're listening carefully and you know what normal sounds like, that's a very important thing. Or you know what normal looks like, what it feels like. It takes time to establish that. It could be in terms of weeks or months. There's always the anecdotal stories of the crew member on a submarine that hears a squeeze, a change in the tone that he associates with changing in depth, and he reports it, and suddenly the boat is a little more concerned that they didn't know they were changing in depth. It takes that sort of awareness in the vehicle you're living on, and that's separate in a sense from the engineering side of it, where we actually can take the data and have people who are experienced with the data, as we are, mission control down here with the space station. They can look at the information they get back on the loads and the monitoring of like the CVMs and that, CMGs, I should say, the control moment gyros. They can look at that data and they can tell you ahead of time how they're operating. And that real-time monitoring is key to make sure that the vehicles are safe to live on and operate.
So you're talking about the aware user.
Yes.
How important do you think for when you're doing long-duration space exploration, are those automated systems going to be for allowing you to?
Well, that's actually something I've put a lot of thought into. On a submarine, we were, we had initially started off with like a vibration monitoring system. The electrician, we'd have to go out to each individual pump. We had points that we could take, trying to get that wired in to a continuously monitoring system, or the ability to monitor when we wanted to. And I think that capability is even more important on like a space vehicle where you don't have that size crew, for one. You're not going to have the same number of intelligent operators out there listening, aware of everything that's going on. So they're going to need that data, but you'll need people on the ground who can read and understand that data so you can pick up the problems before they become problems, because oftentimes you can change the way you operate to allow you to operate for a longer period of time or more safely with a degrading system as opposed to a failed system if you continue to operate as it is. So as we go forward, we need to look and figure out how we're going to do that assessment without sort of the crew time and the crew tasking, the crew members there to do it. We can obviously send the information back to the ground where we can have whole teams look at it. But it's always going to be that first cut as it passes through. That's the guy that's going to pick up the problems initially. So any vehicle you build at this point, you really need to put in different monitoring systems. You can imagine all sorts of interesting ways of looking at fluid systems and piping and vibration on pumps and motors and structural measurements that can help you understand the performance of the vehicle. That data just needs to get back to the ground or back to where the people can assess it. On a submarine, obviously, it was on board for most, but we would send data off periodically to get other people to look at it as well. But it's vitally important for the long-term health of the vehicle, and it might lead you to change the way you operate to allow you to complete a mission or return safely if it's a system that's degrading rapidly, as opposed to if something fails outright that you could have detected earlier. Usually that's a lot worse than operating with a degrading system.
So obviously knowing your system as it's degrading is important, but you've had a lot of experience with EVAs and going out and fixing things after they've broken.
Yeah, yeah. Unfortunately, it's usually when you do stuff. I had a lot of construction, which was good. On STS-126, we went out and looked at the starboard sarge, the large rotary joint, which had damage to the surface of one of the bearings, and they had detected the anomalies in the vibration of the array and the motor currents for the drive motors. And when the first people went out and looked at it, you could see the metal filings. So we went and cleaned that up, and we applied a layer of lubricant and returned it to full service, which is, I think, pretty amazing. But what they had done prior to that, they actually had, constrained the operations of that solar alpha joint, rotary joint, so that it would survive. It survived long enough for us to be able to go and do a little bit of maintenance. If they had continued to run it blind to the knowledge that it was not running correctly, you could have seized it up and it never would have been operational. So that's a really good example of where that knowledge, that monitoring of a system allowed us to go and repair it and extend its life. And because of that, we lubricate the other side as well now. And hopefully that will allow it to last the life of the station.
So when you have something that lasts as long as a space station, it's important to kind of regenerate your workforce and transfer that knowledge of operations and how things are run onto the younger generation.
Yeah, and that's an interesting thing, because sometimes the old guys sit around and they tell stories. They've gathered up all this experience over a lifetime of working. Well, the space program is over 50 years old now, and there actually are very few of those old guys left. And the retirement of the shuttle, there was a whole other wave of tremendous experience that walked out the door. And capturing that knowledge is difficult, because a lot of times you learn things as they happen. That experience that you get when something happens, the first time, the second time, that just gets ingrained into how you operate, how you do things. That doesn't always make it obvious that you need to pass that on to the next person who won't have had that initial experience. It's just something you kind of know. So I think that there's that knowledge of how the space station in particular operates as we proceed, hopefully for another 14, 15, 16 years of operation with the space station. We'll see a whole other generation of operators who come along, and it'll be important that everybody that was there when we first detected the motor currents on the Sarge, or we noticed the torn radiator panel. And those items we need to be able to pass on. What were the cues? What were the things that we learned? What were the changes? because if we don't pass that information on, they won't have that knowledge as when something else dramatically changes. At the same time, having a history of this, having that long-term data that you've collected over time, so you can see how something degrades over the life of the vehicle. What we learn from this vehicle will be tremendously helpful as we go on, provided we learn the lessons and we understand how it's going to degrade and what that means operationally, and how we can extend operations to meet the requirements and what we need to do along the way. And what systems, what knowledge are we missing? You know, what was not built into the space station that would have been helpful along the way, that would have given us a little better insight into its operation and its aging process. That'll be interesting to see over time.
So what can you say to students to help inspire them to take up fields, particularly in like NDE?
Well, see, as I was discussing earlier, NDE is such a broad, all-encompassing term. I know from my experience, I had the good fortune of being engineer of a submarine, and spent a little bit of time in a shipyard environment, actually even as a junior officer. I think I spent a lot more time than the guys actually wanted me to, you know, talking to the sonar techs, talking to the electricians, talking to the radiographers as they came on board, the ultrasound technicians. I always had a lot more questions, because it's an amazing concept that you can do something that's, you're not violating the operational construct of the system, whether it be the piping system or the pump or the motor, and you're learning a lot. You're understanding how it operates within it, you know, and it encompasses such a broad range of science. Actually, you know, I had a professor when I was in graduate school who said, "A wave is a wave." He had actually been a nuclear engineer, and he was teaching acoustics at Woods Hole. And he said, you know, it really is all part of the same problem, you know. And he was doing acoustic tomography, which to assess ocean environments, but in essence, that is ultrasound, you know, and a different frequency range, different scale. But it's, you know, understanding the information you're getting back and what that's telling you is incredible. And then for me, it was, you know, you see this piping system, and you know fluid is flowing through there. Over time, what is that doing to the interior of that piping? Is it corroding? Is it just eroding? Is it staying pristine? Is it putting a nice little protective coating of something else on there? So the ability to look at that and assess that and understand those aspects of the system as they get used is pretty cool. And, you know, in a lot of ways, it's very exciting. And yeah, I probably asked way too many questions of those guys. Who knows how many man hours I used up quizzing them, because I just think it's a very exciting field. Actually, fields. I actually used an IR camera. We had an IR camera on the boat, and we had used it on board. We had it on board for firefighting reasons, but we had started to use them for cable inspections, and we were able to identify different, you know, cables with different problems and get them repaired by using an IR camera. And so I think learning from that, it's just amazing what you can do with some of these techniques, and such a broad just wealth of places to look. And it extends, you know, what you learn maybe in one area, as I pointed out, will carry forth into other areas as well.
Well, Steve, thank you so much for coming to talk to us.
Oh, my pleasure. It was really a lot of fun. Very exciting field.